Hello, in this video, let me talk about how to build the neural network models for numerical predictions. Okay. Before going into the details, let's review the apply function in RL. Okay. So let's go down. All right. So apply function, and as you may remember, question mark, and then whatever the function name, and then you're gonna get some explanation about that function. Okay, so apply function is very convenient when you apply a function for each row or column in a data frame or arrays. Okay, so you can read it later. So let's build some data frame. Okay, so to do that, let's build two the vectors, vector x and vector y. Okay, so vector x is composed of 1, 2, 3. Remember C as a combined function. So we have x. So if you look at x, obviously it's 1, 2, 3. And we can build another vector, y. Okay, if you look at y, and then 4, 5, 1. And then we build a data frame using those two vectors. Okay, I hope you remember data.frame function. Okay, so if you look at so then it's we have a data frame composed of the vector y and vector x and vector y. Okay, all right, so it's going to look like 1, 4, 2, 5, 3, 1. Okay, so what we want to do is we want to calculate the maximum. For example, we want to calculate the maximum for each row or for each column. Okay, so let's take a look at how to calculate the maximum for each row. Okay, so first row maximum is 4, second one is 5, the third one is 3. Okay, so we can use a max function. So max 1 comma or nothing. So this is a first row. So if you do that, they have a 4 obviously, and then you can have for the second row you have a 5. Okay, 5, and for the third row 3. So of course you can do this way, but if you have many rows, like hundreds of thousands of rows, this seems pretty boring. Okay, so there should be a better way of doing it. Yes, so there is a better way of doing it. So you can use apply function. So what apply function is, you basically apply max function for each row. The one means row, for each row of data frame, okay, or array. Okay, so if you do that, you can have 4, 5, 3. So you don't have to use a max function one by one. So let me read that again. So read it this way: you apply max function for each row of data frame or array. Okay, does that make sense? All right. Let's look at the next one. So this time what we want to do is we want to find the max function, maximum value for each column. So the first column, the maximum is 3. The second column, maximum is 5. Okay. So to do that, we can do one thing at a time, one column at a time. Okay. So max, and then the first column. So that is 3. Okay. And the second column, 5. Okay, yeah, so it works, but if you have many columns, if you have hundreds of thousands of columns, again, this could be extremely boring. Okay, so instead, what we can do is we can apply a max function. We can apply the max function for each column. The 2 means a column. So we apply max function for each column of data frame. Okay, or array. Make sense? So in that case, then we have 3 and 5. Okay, make sense? So let me say again. So you apply max function for each column of data frame. Okay. All right. So now you can do the same kind of thing using different function. So for example, hey, we want to find the minimum values for each row. No problem. So we can say apply min function. Min function provides a minimum value. So apply min function for each row of AHA data frame. Okay. So 1 to 1. The next one is a range function. So we can say, hey, apply range function for each row of AHA. Okay. So let's look at the data. So AHA, we have the first row is 1, 4, 2, 5, 3, 1. So range should be what? 1 to 4, 2 to 5, and 1 to 3, right? Okay, so let's do that. So the first, so we have a 1 to 4, 2 to 5, and 1 to 3. Okay. Also, we can use a sum function, so we can add all the data by each row. So apply a sum function. Okay, sum function for each row of AHA. Okay, so 1 plus 5 is 5. 1 plus 4 is 5. 2 plus 5 is 7. 3 plus 1, 4. Okay. All right. So just like the previous case, now we can apply these functions for each column. So like this. So find a min function for each column of AHA. So min is 1 for X, the first column. Min is 1 for the second column. So we have a 1, 1. Okay. Also, we can find the range for each column of AHA. Okay. So as you can see over here, so 1 to 3. Okay, and 1 to 5, 1, 3, 1, 5. Also, we can apply sum function for each column. So if you add these numbers, then we have a 6 and 10. Okay. All right. Now let's try to apply a which max, which min function. Okay. Which max and which min is pretty convenient when you try to find the location of the minimum data and the maximum data. For example, remember the AHA? So AHA, we have, well, let me show you AHA again. So AHA, we have 1, 4, 2, 5, 3, 1. Okay. So when you try to find the max on X, okay, so that is what? The third one. 1, 2, 3, the third one. Can you see that? So which max X? That's number 3. The location is 3. As you may remember, in R, the index starts from 1 rather than 0. Okay, so be careful. How about which max Y? So 5 is max. The location is what? The second 2, right? So what we want to do is instead of using which max or which min for each row or column, we can use apply function. Okay, so apply which max for each row of AHA. Okay, so if you do that, so for the first row, okay, and then there's a second one, so 2 to 5, second one, so 2. For the third row, that's the first one, 1, so 2 to 1. Okay. Also, we can use the which max for each column. Okay. So as you can see over here, so let me say again. So apply which max for each column of AHA. Okay. So as you can see over here, the first column 1 to 3, the 3 the largest. Okay. So 3, and then 4, 5, 1. 5 is the largest, so 5. 2. Okay. So 1, 2, 2, the second one. So we can do the same thing for min and for which min for each row, and the which min for each column. Okay. All right. So I hope it makes sense to you. And so using these functions, we'll look at how to build the neural network models. Okay.